Here is a citizen, Mr. Smith, on his way to work. Hello, Mr. Smith. Hey, you forgot your hat. Yep, you left it right inside there. Don't mention it. And here's Betty Smith, headed for school. Hello, Betty. Swell, kid. Finally, Mrs. Smith. Hello, Mrs. Smith. And what a nice new vacuum cleaner. Really a wonderful piece of machinery, isn't it? Those fan blades inside that suck up the dust are whirling around, well, more than 3,000 times a minute. Why, 40 years ago, Mrs. Smith, there were few turning parts, even in factories, that approached the speed of the rotating blades in your cleaner. Yes, mechanical parts that go round in so many now commonplace objects are far faster than such turning things as existed only yesterday. And they really can take it, too. From bicycle wheels, whoops, as Betty goes down the street, to the shaft and gears of the equipment that builds streets. We expect them to stand up, to keep operating like new. And they do. That goes for every kind of turning thing. For the wheels of Mr. Smith's car, for the wheel-like mechanisms under the hood and elsewhere. Now in the place where Mr. Smith works, say the door. Yeah, the door of your car. Forgetful fellow, isn't he? Now in the place where Mr. Smith works, there's a flock of industrial grinders, precision grinders. Each one revolves 10,000 times a minute, day in, day out. Yet over years of grueling service, a unit like this needs comparatively little attention. Grandpa Smith's farm machinery depends on other kinds of turning parts, the heavy-duty ones of American agriculture that have to cope with big loads, great strain and stress. Subject to even greater loads, greater strain and stress, are the turning parts of American heavy industry. Those in the steel mill, for example, where Grandpa's tractor had its beginnings. For today, it takes turning things to make things. Yes, there were wheels and shafts and rotating units when Grandpa was young, but not many of them. And what there were could not compare in efficiency with the ones we have now. No, in Grandpa's day, they had nothing like these, the wonderful revolving mechanical devices that serve you and me. Devices that generations of inventors worked on and slowly improved, but which only in our own time dramatically reached technical perfection to open up new vistas for American enterprise and for American living. What happened? How do they reach that perfection? Well, if we look to the turning point of most any modern rotating piece, we can see before our eyes the turning point of our entire machine age. For every spinning thing, everything that goes round in mankind's wonderful scheme of things has to have something to go round on. And that something is called a bearing. It's inside there. It's what the wheel spins on. It is called a bearing because it bears the weight and the strain. It's the most important part. This has been so since the first turning object. Without the bearing, the wheel would be useless. Even primitive man was dimly aware that something that turns can be no better than whatever it turns on. The first wheel revolved, but that was just about all. It had practically no bearing, just a hole in the wheel that rapidly wore away. The engineers of ancient Greece and Rome did a lot better insofar as eye appeal went, but not much better when it came to performance. The best they could do in the way of a bearing was basically little different from that of the caveman. By the 18th century, imaginative French and English carriage builders knew what kind of a bearing they would like for their beautifully designed wheels. a bearing that would last as long as the wheel itself. But they couldn't build one. They didn't know how. And so they had to content themselves with the same old axle, the same simple hole in the wheel. Metal construction was some help. So was axle grease. Naturally, though, if the load was too great, if those handsome wheels turned too fast, the bearings became hot. They wore down as rotation occurred. That's why covered wagons collapsed on the American prairies as the West was opening. Bearing trouble. That's one reason why early railroad locomotives and cars developed dangerous hot boxes. Hot because of friction, where the wheel turned on old-fashioned bearings. Yes, because of bearing trouble, the usefulness of everything that revolved continued to be limited even as the 20th century opened. The engines were there then, capable of generating plenty of power. And the creative mind was there. But the creative mind knew that one thing threatened to halt the march of machinery, and that one thing was friction. The dictionary tells us that friction is the resistance to motion between two surfaces in contact. But to men who want to build better machines, friction is an enemy as old as history. And so such men concentrated on this friction problem, this bearing problem. They came to realize that unless the parts that turned on bearings could be driven faster and harder without destroying the bearings and the machines too, mankind was doomed to live forever in an age of limited production, restricted use, comparative drudgery. Friction, resistance to motion, had to be overcome. So let's take a look at this friction problem. Let's see what it's all about and how it's been solved, for it has been solved. If you take a heavy block of rough metal and try to push it across an ordinary surface, in the first place, it's difficult to start. Static friction is present. And when it does start, sliding friction occurs. The surfaces of the block and the table conflict with each other. The metal is wearing away the tabletop. There is resistance to motion between two surfaces in contact, just as the dictionary says. If we increase the load, the friction increases. More power is required to stop the block and keep it moving. But if we put something that rolls between the two surfaces, between the tabletop and the block of metal, the block will start easily and it will keep moving. There's no perceptible wear. Sliding friction has been eliminated. Instead, we have rolling motion. What a difference. And there's even a greater difference when makeshift rollers are replaced by precision-made rollers, and they move between precision-made surfaces. There's hardly any resistance at all. Even when the load's increased, scarcely any effort is needed to start things going, and even less effort to keep them going. And the same is true if the turning elements are precision-made balls. With the ball, as with the roller, there's a minimum of resistance, a minimum of effort required, whether the load be light or heavy. But what has all this to do with bearings, with wheels and gears and revolving mechanical parts? Well, plenty. Because when the possibilities of this principle were realized, a new kind of bearing came into existence to become the turning point not only of the modern wheel, not only of the machine age, but of civilization as we know it. This is the basic idea of the bearing that has revolutionized industry, the bearing that finally overcame friction, the anti-friction bearing. With it, instead of sliding friction, there's rolling motion. No matter what form it may take, whether it utilizes balls, as in this example, where we have a ball bearing, or whether it utilizes straight rollers, as here, where we have a roller bearing, whether it be made with tapered rollers, another type of roller bearing, or with barrel-shaped rollers, or very slender rollers in what is known as a needle bearing, no matter what the form, whether it be a ball bearing or a roller bearing, it's an anti-friction bearing, the bearing that overcomes the old bugaboo of industry, bearing trouble. Of course, they didn't come into being just like that, overnight. It required long years, much research, and the many and complicated problems that various types of friction present. In scores of American plants, new processes, new methods were developed by American scientists. Research had to be done in metallurgy and in tool and machinery design to bring anti-friction bearings to their present high state of efficiency. American steelmen were called upon to provide the cleanest steel in the world. Many kinds of steel that through various special types of furnace treatment could be made as hard as required or as tough as need be to take every advantage of that wonderful principle of rolling motion. Fine steel deserves fine processing, so American engineers created the necessary methods and machines, the presses where steel bars are converted into steel balls. When they're as large as this, it's done hot. Smaller sizes are usually handled cold. Here's how the balls are made round. By being ground down in a continuous operation, a ton at a time. These grinders take many forms in different factories, but the principle is always the same. You can't see much when the machine is running, so let's stop it and take a look at the inside. That grooved surface is a rotating grindstone, and right opposite is a grooved metal plate. As the balls pass between those surfaces, a small amount of steel is ground off the high spots. After several hours of this, there just aren't any more high spots, and the balls are the proper size. Here's the whole cycle. Watch. First, the roughly spherical lump as it comes from the press. Then its succeeding stages till it becomes a highly polished anti-friction element, accurate in size and roundness to within 1/4 of 1/10,000th of an inch, 1/20th the thickness of a human hair. Here's proof. The runways of these precision devices are delicately tapered. Note that each ball drops through at the same point. If they were not all alike, some would drop through at one place, some at another. Every one of this batch is just right. Rollers, too, must be just right. They, too, get their start in a type of press. This one is automatic. It's forming tapered rollers which eventually are processed by their own special type of grinders. Straight rollers, that is, rollers which are cylindrical in shape, receive similar treatment. They go in on one side of the machine looking a little dingy, but when they come out on the other side, what a difference. But balls and rollers are only part of the complete anti-friction bearing. There are outer and inner races and rings, each of a special steel too. Sometimes races and rings are machined and shaped automatically, several units at once, sometimes singly, like this big fellow here. Again, the versatile grinding process is utilized to achieve exact dimensions and to put a mirror-like finish on the surfaces that will be in contact with the rollers or the balls. Yes, in the design and building of every piece of machinery used in bearing manufacture, engineers have concerned themselves especially with the problem of precision. Industry has been using bearings of more than 20,000 types and sizes. It requires a large proportion of what it uses to be accurate to an amazing degree. Bearings that turn smoothly, quietly, rotate truly. All this calls for utmost precision in manufacture. So equipment, procedures to make such balls and rollers and races had to be devised. And at the same time, equipment for testing, for checking and double checking. Sensitive gauges so delicately contrived that where super precision is desired, they can detect in a finished ball or roller or complete bearing a deviation of as little as 1/1,000,000th of an inch. All these and countless more special units had to be created before modern anti-friction bearings became a reality. No one man was responsible, no one manufacturer, but many minds, many skills have given us these wonderful trouble-free bearings that we all depend on in one way or another, but which few of us know exist because they perform so well, so unobtrusively. Look at this commonplace yet important piece of mechanized household equipment. It couldn't do its job without anti-friction bearings. Bet you never realized there were such things in that washing machine, did you, Mrs. Smith? Yup, it's us again. Well, you know now. And you also know the reason why that washer has given faithful service and been so economical to operate. And your oil burner, its anti-friction bearings guarantee its fine performance, prove it's up to date. Modern things have anti-friction bearings. Old-fashioned ones don't. No wonder that fuddy-duddy lawnmower in the basement has been put away. No wonder the Iceman doesn't stop here anymore. And the same kind of bearings that operate in all these smooth-running devices that we take so much for granted are the same kind of bearings that help build them. The same kind of bearings that help build a Smith house. The timber for it and every house came from a mighty forest where heavy equipment works constantly without bearing trouble because at the vital turning points are you know what. Yes, anti-friction bearings are doing for many industries what they did from the beginning for the automotive industry. There's not a car, truck, trailer, or bus that doesn't roll on them, that wasn't manufactured with the help of them. And as loads increase, as speeds increase, as new requirements arise, the proper anti-friction bearing is always available, ready to do the job. And it looks as though a job is going to be done on somebody that's forgotten about the traffic regulations. Well, Mr. Smith, and here's about the only transportation problem that cannot be smoothed out by anti-friction bearings. Airplanes today literally fly on them. A big passenger job like this, the kind that can whisk us across the Atlantic in a few hours, requires more than 2,000 various types. They're throughout the ship, from husky landing gear to delicate gyro compass, from sensitive drift indicator to roaring supercharger. There are trains now that run so smoothly, passengers hardly realize they're moving, that travel at amazing speed, yet inside, you'd never know it. What a difference between this and the jolting, swaying cars and locomotives that operated on old-fashioned bearings. Thanks to the constant effort of the railroads to improve service and equipment, there are more and more trains now that roll on or freight. Such trains indicate forward-looking railroad management. Here is a locomotive equipped with anti-friction bearings. Here are some girls. Yes, this is only a stunt, but it will prove that where you have anti-friction bearings, you need less power to start, less power to keep going. 4 young women. Together they weigh only 410 pounds. A giant of the rails weighing 860,000 pounds. Okay, let's go. Before anti-friction bearings, you could have crowded the track with husky men, tugging and straining, yet they never would have been able to budge an engine this size. But look at this. Yes, it's a fact. Today, the problem of friction is no longer a problem. Today, it's rolling motion, anti-friction bearings, for they're here, now at your service, to fill every need, to be used at turning points everywhere, so that jobs can be done better, more easily, more economically than ever before. They're here to serve mankind in thousands of ways that are new. The industrial engineer today may let his imagination roam where it will. No longer does the old enemy, bearing trouble, limit his ideas. Instead, his ideas are given impetus, wings. He knows that with bearings such as he has to work with now, American anti-friction bearings, we can build this machine age of ours into the mightiest age of all time.